quadratic, standard quadratic form. Ax squared plus bx plus c. Even though it's negative, it doesn't matter. It's still in that format. What we need to do is complete the square. When we complete the square, we have to move our last term and move it to the other side. So our format for this is going to be of some sort. Alright? That's what we're trying to get this to look like. This is not a hard thing to do because all we have to do is move this negative 30 and push it over here to the other side and make it positive. Alright? So we now have x squared plus 10x is equal to 30. That's what we should have right now. What's this little b over 2 squared? And that's like a little formula that we're going to take our value of b and put it in here and find something to add to both sides of the equal sign. So write this down next. That's the next thing. We have our 10, so I'm going to do 10 in parentheses 10 over 2 squared. And you're going to tell me what's 10 divided by 2? Right? And then when we square 5, what do we get?
Square 5.
When we square 5, what do we get? 25, right? This is the value that we're going to add to both sides of this in order for us to complete the square. Alright? So, I'm going to come back over here and literally just go x squared plus 10x plus 25 is equal to 30 plus 25. That's the next step. Alright? There's a reason why we're doing this. Usually, if you're lucky, you'll get what's called the difference of perfect squares and you'll be able to kind of do some fun stuff. This one is not that. But the last test that I took, the test before this last test, it was like this. So part of me feels that they go back and forth in the formatting of the exam, which is a good thing. So we're going to add this up first. What's 30 plus 25? 55, right? So I'm just going to rewrite everything. We're not going to do anything with the 55. It just stays there. That's why I decided to do it and get it out of the way. Don't have to worry about nothing. Now, when you are doing this and we're talking about factoring or anything like that, we have to find items that will add to 10, multiply to 25. What makes this easy is that they're both plus signs. What number do you think will multiply to 25 and will add to 10? 5. Straight up, 5. So, in parentheses, we're going to do x plus 5. That's the next step. Now I'm going to go back a little bit because I asked you guys a question. How do I get rid of something that has an exponent? If it's square, what do I do? Mr. James, square root. So, what we're going to do is, what I just said, if you didn't hear me, was if you have a squared, in order to get rid of a square, the opposite operation is for us to square root each side. Alright? So we're going to square root this side. And square root this side. This we're not going to touch. Algebra 2. We ain't touching that right now. Alright, we don't need to. We keep it like this, but all we're going to do right now is do this. Plus or minus radical 55. The reason being is that we are doing the quadratic. We're doing a quadratic, and in the quadratic equation we have two answers, plus or minus, so we're just going to add that in now because we're done with that side. Alright? Most of the work that we're going to do is on this side. This is also easy. If I have two of them, but I just squared it, how many do you think we have now? I want to get rid of the square. So if I have two of something and I squared it, how many things do I have now? One. I just got rid of one of them. So now I'm left with x plus 5 is equal to plus or minus radical 55. Right? Now.
That's the answer.
No, I'm not done yet. We're almost there. We want to solve this for x first, and that'll be the last answer. So if I have x plus 5 is equal to 0, how do I get rid of this? I subtract. X is equal to negative 5. So our final answer is going to be x is equal to negative 5 plus or minus the square root of 55. Leave it like that. And I think we just do a lot of overthinking, and that's really it. In your calculator, alright, you can find the GCD, which is the greatest common denominator of both of these numbers, or you can just know them. So in your calculator, you're going to go to math, hit, go over to the right to hit number, and then you're going to go down to where it says GCD, which I believe is 8 or 9.
It's 9.
It's 9. So it's going to be, and I have it up there, and that's why I'm looking over there. So on the calculator, you're going to do math. You're going to go over to num, and you're going to go down to GCD, which I believe is 9 dot dot, right? All right. From there, you're going to get a son of a biscuit. Math. You're going to plug in 20 comma 45. So 20 comma 45. Hit enter and tell me what you get.
We gotta close up.
5, that's what you should get. 5 is there because that's our GCD, that's our greatest common denominator. That's what we can pull out of there in order. So there's a way to do it. You can obviously list your factors and then see which one is the biggest one that is common between. So if you don't want to do the math and you want to do it by hand, like Mr. Jones loves to do, we can do, which is fine, 20, and we can do 45. This is for the people that don't want to use a calculator. All right, what are the multiples of 20? We have 1 and 20, 2 and 10, 4 and 5. Is that it? Yeah. Except 5 and 4, we don't have to swap them. 45, you have 1 and 45, 2, nope, 3 and 15, 4, no, 5 and 9. Any more? Of these 20 and 45, what is the greatest common factor between two of them? 5. GCD, just like I said when we had that 3x minus ax, and I said what is common? Our common denominator is 5. We're going to pull it out. But we also have another common denominator. Remember I told you? We have 3 x's here and 1 here. We can pull one out and still keep our x's here. So we're going to pull out 5x and then rewrite everything. So what's 20 divided by 5? 4x squared. And then what is 45 divided by 5? Or negative 45 divided by 5 is 9. So this is what you should have now. You should have your 5x on the outside, and we're going to just carry that down as we go. And we should have on the inside 4x squared minus 9. This is, Fahim, this is kind of similar to like when we just do factoring, but because there's a bigger number in the front, people get confused, yes.
How we get the 4x squared?
So now we're just trying to solve for the.
When we pulled out the 5, we basically divide these two to get the numbers that are inside of here.
So it's kind of like checking it, right?
In a way, yes, but we're not solving for anything. We're just trying to factor and get the factors that are in there. So, did that answer your question?
I still don't get it.
What do you mean? All we did was, you have to think about it like this. I asked you, you found the GCD, right? So now, if you divide in your calculator 20 divided by 5, what do you get? Do it. Right, now do 45 divided by 5, what do you get? And that's somebody learning, you see that? Get it? Negative 9, right? So that's how we got it. Once you pull it out, it's like dividing to get them to a simpler number. Now we're going to expand and make the same 2.
Positive 9 though.
Well, because I said 45. Maybe we would have did negative 45. I just told you to do 45 just because. So, we have, we can split this into 2. 4 into 2 is 2. We can do a 2x here because that takes care of this, one of the 2x's. We can do another 2x here because that takes care of the other 2x's, so now we have 4x squared. Now, do I have a middle term in there? Do I have a b, not a b term, but do I have I don't have a c term rather, up here. So that means that inside of here there's gonna be a number. Basically what I'm getting at is that when you see nothing here like this, or nothing here in the middle, that's basically going to cause you to have a b, you're gonna do a plus and a minus because you need to cancel that out. So you're gonna have 2x plus 3.
So when we don't have a C, we gotta do plus.
When you don't have a b here, rather, when you don't have a b in the middle here, it's basically like you're canceling out that b term. So your terms inside of here are gonna be like a positive and then a negative because you gotta get rid of them. I'm gonna show you real quick why that works. All right, but that's it. This is what you call remember I said a difference of two perfect squares?
So you don't have to solve it?
That's it. You don't need to solve. What are you solving?
So
They said factor. They didn't say solve. Done.
We took the exponent, what, times 3, and
So you just breaking it down to its lowest.
Done. Say it again.
how we get the 3 for an exponent?
This, it was just there.
Oh,
So they gave it to us. So I asked them when we pulled out the 5, I said, we can pull out this x because if we pull out the x here and here, we still have an x squared here, so we can keep going. If it was like x squared, we wouldn't pull it out because we still need to have two different things. Why this works, and what I'm gonna do real quick is show you why this works. Alright? We do our double distribution, we have our 4x squared. This is also what you call a difference of two perfect squares. But this is what I'm saying. Alright, you see how this cancels out already? That's why I'm saying to -9. This cancels out, and it brings me back to what we have up here, and then we just multiply it by 5x, and it'll bring me back to up here. That's it. I'm just checking. This is not what you have to do. I'm just making sure that you guys understand why I did it that way. Alright? All you are responsible for is this. You're not even responsible for this. You can do this in the calculator and just do this, and that's full credit. I'm just giving you notes so that if you don't know how to do it, you can do it. That's it.